Hello, I'm Deborah Dickerson. I'm an associate professor at Virginia Tech in the Grade O Department of Industrial and Systems Engineering. And I'm going to talk to you today about how we might use prevention through design concepts to control health hazards in construction. First, I'd like to introduce you to what I mean by health hazards in construction and how the application of prevention through design is a little bit different when we're looking at this type of hazard. I'm going to introduce you to the history of research in my research group and briefly overview the trajectory of prior work in this area. And then I'll talk to you about our current and ongoing work looking at prevention through design, innovation in different trades in the industry. But first, let's think about health hazards and how prevention through design applies to them and how it might be a little bit different from what you're used to thinking about when you think about prevention through design in construction. First, let's look at the definition of prevention through design, which I know you're familiar with. Prevention through design is eliminating hazards at the design stage. That's what we all know. But each profession, each engineering discipline thinks about the design stage a little bit differently. And I have noticed that people in construction, when thinking about design stage, they're thinking about the stage at which the built environment is being designed. So the designs for the thing that is going to be constructed. And as an industrial engineer, I think about that a little bit differently, and I know mechanical engineers do as well. Each engineering discipline thinks about design of the items that they are designing. So those might be the tools that are used during construction, the hand tools, the larger tools, the pieces of heavy equipment. Whenever those are designed, we can apply prevention through design to eliminate or reduce the risks and hazards. Also, though, materials that are used in construction, those materials engineers who are designing them, when they design materials for construction, they can apply prevention through design to eliminate or reduce the hazards associated with the materials. Same thing with processes and systems. So how the work is being performed. We can design or redesign the work systems and work processes to eliminate or reduce the risks and hazards. Here's a hierarchy of control solutions and how it might apply to the control of health hazards. Of course, at the top, our top goal, our optimal goal would be to eliminate the hazards. That's not always possible, especially with health hazards. For example, silica is ubiquitous in all earthen-based materials that are used in construction. So it's really not possible to eliminate silica from those materials. So we might have to go down the hierarchy to find a solution that would reduce the exposure or reduce the risk to workers. So we might get to containment and removal, where we're going to try to isolate the worker with a ventilated cab on a piece of equipment. Or we might ventilate a hand tool to capture and remove the contaminant from their breathing zone. Or we might use wet methods where we're spraying water onto the substrate so that dust is not generated into the airspace. And so we have various different approaches. We can use work process design, where we're going to, we haven't been able to eliminate or reduce the level of hazard, but we can reduce the amount of time that the workers are around that hazard. So therefore, we're reducing their overall risk in that way. So these are all different design approaches that can have the end result of reducing the risk to the workers. And of course, at the bottom, we have our personal protective equipment, which we're all trying to not use. So the goal of prevention through design is to reduce or eliminate those hazards so that we don't have to rely on personal protective equipment for workers. There are two different categories of health hazards that I'm going to talk to you about that I just want to introduce you to. First is chemical health hazards. These would be things like vapors, fumes, dusts that are in the air that can cause adverse health outcomes for workers. And I've spent a lot of time working with the dusts in construction, and some of the best ways of designing equipment to control dust would be wet methods where we're spraying water. As we see in the picture on this slide, that concrete saw is spraying water onto the concrete to reduce the dust generation. But then there are many different ventilated tools available on the market, or ventilated attachments, vacuum attachments to collect the dust that's generated, and other ways of designing the tools to reduce the risk. There also are physical health hazards associated with construction work. Noise would be the most familiar of those. Physical health hazards are forms of energy that can cause adverse health effects on workers. And there are different ways that we can design the work and the materials and the equipment to reduce noise. And we can do that through solid vibration control or air turbulence control. Vibration, very similar to noise, is also a hazard to workers in construction, either to their hands and arms or to their whole body. And there are various ways that we can design either the tools, equipment, or the gloves that the workers are wearing to reduce the transmission of that vibration from the equipment into the worker's body. So there already are many solutions for noise and vibration in construction. But what I specialize in, and what I'm going to talk to you about the rest of this time, is control of the chemical health hazards. So for the last, I guess it's almost 15 years, my research group has been working on controlling chemical health hazards in construction. And here's a trajectory of the work we've done so far, which brings you to the project I'm going to talk to you about today. I started out looking at the drywall trades and have branched out into other trade sectors of construction. And in all of these projects, I first start out by identifying whether these control technologies are being used, how familiar the construction firms are with them, and then I've measured perceptions that might impact the decision to use the new tools. Things like the perception of risk, perceived benefit of the tool, perceived ease of use of the tool, and then any barriers that might exist to adopting the new tools. So where we are now is we are looking at two trade sectors, the concrete masonry trades and the asphalt roofing trades. And the reason that we're looking at those, first of all, concrete and masonry, of course, have exposure to crystalline silica or respirable quartz, and that is a known lung hazard. It causes silicosis, which is a fibrotic disease of the lungs, which can be quite debilitating and can lead to death. And then also it's been associated with cancer of the lung. And OSHA suggests that these trade groups have greater silica exposure than any other construction trades. And there are many very highly effective design solutions to either eliminate or greatly reduce this risk. We have ventilated tools like masonry saws, handheld saws, and they can reduce the dust by 80, 95, 96%. These are very highly effective methods of reducing this risk. So we have them for many of the major tools that are used, rotary hammers, angle grinders, all have either come equipped with ventilation or have aftermarket devices that can be attached to collect the dust. And then in asphalt roofing has been found to expose workers to cancer-causing chemicals in the vapors that are emitted from the liquid asphalt. Many animal studies have shown a link between exposure to these chemicals and the development of various cancers. There have been epidemiological studies that have linked this type of work with excess incidence of lung cancer and also cancer of the upper airways, the mouth, the throat, the sinus cavities. And NIOSH conducted a health hazard evaluation and concluded that roofing asphalt fumes are potential human occupational carcinogen. And so because of that, I chose to look at this trade and look at what we can do to try to improve the health of these workers. There are many solutions, many engineered solutions, prevention through design solutions that can reduce the worker exposure. And so what I wanted to know is, are these being used? There are things like insulated kettles and hot luggers. There's fume suppressing asphalt that can be used. There are many different varieties of local exhaust ventilation systems. The main exposing tasks in this trade are operating the kettle where the asphalt is melted, and also applying the asphalt on the rooftop. And so there are various solutions that exist to reduce the exposure. What we did was we selected the prevention through design innovations that have been found experimentally to reduce the worker exposure. And here's a list of the innovations that we included in our survey in our study. Oh, I would like to mention that welding is on there too. I'm not talking about that today, but that is an ongoing part of the project. So the methods were, we did a telephone-based survey using a validated survey instrument. We had questions pertaining to familiarity with these different devices, frequency of use, some of the benefits, perceived benefits and perceived barriers to using them, perception of health risk associated with the chemical health hazards in these trades. And then we had some open-ended questions where we just solicited free response to learn more. So this was a convenience sample. We had membership directories from several of the trade organizations, and we did get a 42% completion rate from this telephone calling method that we used. To analyze the data, we analyzed them descriptively, which I will show you on the next few slides. We also did a multivariate analysis of variance, statistical analysis to look at a relationship between some of the different variables such as firm size, age, gender, and some of the psychosocial constructs that we were measuring. And we used JUMP to do these analyses. So the results for asphalt roofing, we found that there was no significant impact from the age or gender of the respondent or the size of the firm and the percentage of the work that is being specified using the control technology. So there's no connection there. We found that the psychosocial constructs that had the greatest bearing on the decision makers' decision to adopt the technologies were perception of risk, whether or not they perceived a health risk associated with asphalt vapors and fumes, the perceived benefits of using the technologies, and the perceived ease of use. So those were the constructs that seemed most important in the asphalt roofing trades. None of the fume control technologies were widely used. The most widely used being the insulated kettle and insulated hot luggers, which are only used at 39.6%. of the time. So less than half of the respondents reported perceiving a health risk to the workers from the asphalt. And 77% of the asphalt roofing jobs did not require emission control. So we have a lot of work to be done there. Concrete masonry, again, age, gender, firm size had no bearing on the answers, it would seem. We found that the psychosocial constructs that had the greatest impact were perceived benefit and perceived risk. So risk associated with the health hazard and the perceived benefit of using the different technologies. Wet method systems and dust collection equipment are the most frequently used. Decision makers responded that they either always or regularly use wet method systems and dust control technology. Wet method 65% of the time and dust control 58% of the time, respectively. So that's pretty good. Whoops, sorry about that. Here we have the perception of health risk. We asked several questions that were aiming at the perception of risk to worker health. And at the top of this graph are an aggregation of the questions that we're trying to answer. How severe do you think the disease will be? If someone becomes ill from this dust, how severely ill will they become? So that's severity of health risk. And then on the bottom of the graph, we have how likely do you think this dust is to cause this health outcome? So two slightly different questions here. How likely are your workers to become ill from exposure to this dust? And then how ill will they become when they're exposed? So you can see for the concrete and masonry trades, we have quite a large percentage saying either they strongly or somewhat agree that it's a severe health outcome. So we had I think it was 72% said they agree there's a severe health outcome associated with silica. That's not surprising because there is a lot of information about silica, new regulations, a lot of things in the press about this, so I'm not surprised. And then how likely are the workers to become ill if exposed to the dust? Nearly 80% said somewhat or strongly agree that there is a risk there. So that's not surprising. Then we have the usage of the different devices. So for each of the systems, we have wet method, dust collection, isolation, sweeping, compound. And for each of these, we have the bars from left to right, always, regularly, sometimes, rarely, never, and refuse to answer. So you can see in masonry and concrete trades, wet methods are being used most often, and then you can see dust collection, and then the others are not used as much. Again, not very surprising. Then we get to the roofing asphalt, and we have, again, the same health risk questions, but we have fewer respondents perceiving that their workers will become ill and perceiving that it will be a severe health outcome from exposure. So we have some work to do there to educate on the health risks involved. Then we have the usage information on these different systems. So we had a tanker delivery system, insulated, hot luggers and mechanical spreaders, some mechanical systems to do the application on the rooftop, insulated kettles and hot luggers, low fuming asphalt, and kettle guards. And you can see that very few of these respondents are using these systems. As I said, 77% of the work is not using any controls. So our ongoing and future work, we're continuing to look at the psychosocial factors that influence decision makers. We are developing an intervention, a training-based health promotion intervention to try to influence these decision makers and improve some of these metrics that we've quantified here for you to try to ultimately increase the usage trends. And some conclusions. Prevention through design approaches do exist to control health hazards, and they are effective, but we have work to do to improve the stakeholder willingness to acquire and use these tools. So interventions targeting the perceptions of risk, the ease of use, the benefits to their business could have an impact. And in our ongoing work, we are hypothesizing that it will have an impact if we can impress upon them that there are benefits to using these devices. So thank you for your time today. I've enjoyed sharing this information with you, and I look forward to talking with you all at the conference.